All right, on part one, we discussed question two here. We were discussing the base. This base is 4 units long, and this base here is 10 units long. And the question was, how do you take this large shape and make it smaller? So, big times what makes smaller is the question. Now, 10 times what is 4 is the question, and I'm assuming 1's not going to work. 10 times 2 is 20. 10 times, you're making it worse, so it's got to be less than 1. Now, your options are to do 10 divided by 4 or 4 divided by 10, but your answer has to be less than 1. On a calculator, if you do 4 divided by 10, you will get 40 cents. And if you did 10 divided by 4 on the calculator, you would get 2 something. 4 times 2 is 8, and 2 left over. You get 2.5 actually. But 2.5 is still not less than 1. This is still wrong. Even if you did it backwards, you should know it has to be less than 1. So your answer is 4/10. By the way, that reduced down to 2/5, and that Next, let's play a game. We're done with dilation, so now we can play Do You Know? Do you know the Muffin Man, or at least the transformation guy? Now, here are 6 questions listed. Now, my question to you is, which one of these is rotation, dilation, reflection, and what's that one I'm missing? Yes, you're right. It was translations. Now, at this point, I would like you to stop the video and answer those 6 questions using those 4 answer choices. Here are the answers. The first one is dilation. I can prove that. You have a coefficient in front of x and y, and that coefficient is 2. This means times 2. 2x, 2y. That's a dilation. And by the way, I'm making it larger, twice as large. The next one. That one is a reflection over the y-axis. I can prove it. That's not rotation because they should be flipped, or the y should be negative. So it's a reflection, and the question is it over the x or the y? The x is negative, so you're doing the y. By the way, the mate is down here. That's also not rotation. And this one's negative, so you're reflecting over the x. Now this one appears translation, and I can prove it. Add and subtract are all translations. Rotation here. Remember, flip, don't flip. This is don't, and they're both negative. Now, what about this one? That is an error. I did that on purpose to see what you knew. In order to do dilation, you got to use same number. You can't pick and choose different numbers. That is an error. Next, I want to discuss congruency and orientation. Now, I listed your 4, your translation, dilation, reflection, rotation, and those are all transformations. Now, my question to you is, which one of these preserves congruency? Which one of these preserves orientation? And how do you know as a hint, as in what these 4 look like on that rule? Now I can work this backwards. The translation looked like what? Yes, you're right. It was like x plus 2, y minus 3. That would be the ending. What about dilation? It would be like 2x, 2y. What about reflection? You would see that x is negative, or you would see y is negative. And rotation, you would see those 3 that we memorized. So flip, don't flip. Flip, don't flip, that 1, 2, 1 pattern. And so there's your patterns. Flip, don't flip, the negative, both negative, and then the first one's negative. Now, so I've got your hints written. Now, back to orientation and congruency. What does congruency mean? Yes, same size, same shape. How about the word equal? They are equal. So if you do translation, in other words, you slide that shape, did you change the size of that shape? Is it larger, smaller, longer, taller? I don't think so. So the congruency is okay. It's preserved. What about dilation? Dilation means you make it bigger. So how can it be equal if you made it bigger? You do not preserve dilation. If you flip something over, so if I turn your paper over, it would get bigger, or if I turned it back, it'd get smaller? No. Reflection preserves congruency. Rotation. So if you turned around 3 circles, you would lose 5 pounds? I wish. Rotation preserves congruency. What about orientation? How do you remember orientation? Well, in class we used a clock. So here's my example. If I gave you a large triangle and a small triangle, and I labeled this one A, B, C, and I labeled this one A, B, C. They look different. They're not the same size, but did they preserve orientation is the question. Now, you could draw a little clock on them, big clock maybe. And which way does the clock go? It goes clockwise. And if in doubt, find a clock. Now, if I put my finger on A, I'm going to go to B, and then I'm going to come right back to C. So this one here is ABC. I started at A, I'm going to B, coming back around C. What about this one? Put my finger at A, B, C. I'll test again. Here's A, B, C. Those match. So this orientation is fine. Now that was dilation. So I can come over here and say dilation orientation is okay. Now it wasn't okay for congruent, but it is okay for orientation. Now the question is, which one of these are okay? Translation is okay. Rotation is okay. Reflection is not. I can prove it. What if you have the same two triangles? Here's your y-axis. This one was A, B, C, so this one's A prime, B prime, C prime, because this is reflection. So let's test with our fancy little clock. And remember, draw your directions in. So I'm going to start with A because that's the way I did the ABC song. A, B, C. Test again. A, B, C. So this one's A, B, C. A, B, C. What about this one? Start at A. A, C, B. A, C, B. These are not equal. So reflection does not work. And that is what I marked on my sheet. Thank you for watching my video. Good night.